Hello students and welcome to Flipped Video 2.2 on frequency distributions and measures of variability. This corresponds to book sections 1.13 to 1.16. So when we talk about frequency distributions, we're talking about tables or graphs that show how often a number or score appears in a data set. This can be a very helpful visual representation of data that you've already taken down. So instead of looking at numbers, you can see how easily it is to understand this information because you have it visually represented. So instead of just looking at numbers and counts of, for example, in this table, people who have a certain number of pets, it is tallied and represented in this table so you can easily understand it. So if I wanted to ask you how many people in a certain class or group had 2 pets, instead of just looking at random numbers of 2s in a data set, you can look across and see that the frequency of people who have 2 pets is 5 in whatever group this is. Tables are usually more beneficial when you have smaller sets of data like this one, but it sometimes may be easier to understand if you have a more visual representation. And so we'll use things like histograms or bar graphs to represent data. So if I wanted to take the scores on a certain test or quiz that I gave and I wanted to see the spread of data, I would do something like this. I would put it on a histogram and I would be able to very easily see the spread of scores that I have. Again, the point of frequency distributions is to more easily get a bigger picture of a certain data set. So instead of just looking at numbers of different scores, I'm looking at this table that tells me, oh, the mode of this distribution is 45. And I can see that it's spread all the way from the low end at, you can't see that number, all the way up to the high end at 95. So again, it more easily represents a data set in a visual, easy to understand method. Another way that you can represent a histogram is by using a polygraph or a polygon, or a line graph. Here you have a polygon laid over a histogram, so you can see that it represents this exact same information. It's just connecting the data points using a line as opposed to the bars of the histogram. So as you can see, if I wanted to see how many people had a sickness in June, I would just look to where the data point on the frequency polygon was in the month of June and see that it is right here up at the mode. One benefit of the polygon over the histogram is that it more easily allows researchers to see the shape of the data. And so here you can see that it peaks all the way in June and it rises all up until it gets to June, and then it drops off until it gets to December. A popular polygon that you'll see in this class is this, the normal curve or the bell curve. This type of frequency polygon is used when we want to measure things like intelligence, height, or weight. This is what we'd call a perfect distribution, and this will happen most times provided that you have the data from a very large number of people. And so one benefit is that the average, and I'll explain standard deviation a little bit later in this presentation, the average person will fall right up in this middle peak all of the time. And so in a normal distribution, the mean, median, and mode are all the same number, and it'll fall at the peak where this 0 line is. Again, the mean, median, and mode will all be the same in a normal distribution. Now, this distribution is a perfect case scenario, but more often than not, we won't get things like this. More often than not, we'll get distributions with shapes that we describe as skewed. And so here you can see our distributions labeled positive and negative skew. Let's focus on the negative skew curve for a moment. If you look here, you can see that the tail end is off to the left. When determining skew, you look at the tail end of the graph. So when it's negatively skewed, it means the tail is pointing off towards the negative numbers in a distribution. Again, if it's negatively skewed, it means the tail end is moving off towards negative numbers. You can also call that skewed to the left. Now, if we look at this positively skewed graph, you can see that the tail end is heading off towards the right. Positively skewed distributions will have a tail that goes off towards the right end of your graph. Skewed distributions happen when you have a mode that is towards either the high end of your distribution or the low end of your distribution. So in a negatively skewed graph, the mode will be closer, or the mode will be towards the higher end of your scale. And the mean will be on the opposite end, and the median will be somewhere in between. So in a negatively skewed graph, the mode will be on the high end of your distribution. The mean will be towards the low end of your distribution, and your median will be somewhere in between. Take a minute to try and figure out where those measures of central tendency will be in a positively skewed distribution. So in a positively skewed distribution, you should have reported that the mode will be towards the lower end of the distribution, the mean will be towards the higher end of the distribution, and the median will be somewhere in between. A real-life example of a distribution that would be negatively skewed is height of NBA basketball players. Basketball players, more often than not, will be significantly taller than the average person, and so most of those numbers would fall towards the higher end of a distribution. An example of a real-life situation with a positive skew is salaries in a corporation. Most people will have salaries that are on the lower end of the distribution, with a few very, very high people in the corporation, like the CEO, making a very large salary. Take a minute and try to infer what a bimodal distribution would look like using a histogram, and sketch that into your notes. Now that we've looked at measures of central tendency, or numbers that represent the center of a distribution, we're going to look at measures of variability, or how spread out your data set is. The easiest measure of variability to figure is the range, or taking your highest score and subtracting your lowest score to figure out what that difference is, to see how many scores are in between. For example, if the tallest kid in one of my classes was 6'5" and the shortest was 5 foot, what I would do is I would subtract 5 feet. First, I'd convert it to inches, and I'd subtract that from 6'5" after I converted it to inches, and that would be the range of heights of students in that class. Looking back at this normal curve, this one statistical measure of variability is very important, and that's the standard deviation. So what the standard deviation is, literally, it's a measurement that is the square root of the average squared deviation from the mean. In other words, The standard deviation measures how different a set of scores is from the average or the central tendencies. The mathematical formula for standard deviation looks complicated, but if you break it down, you can see that it's really easy to do. And so, if you take it one step at a time, you can see that it is the sum of all of the individual values in your data set subtracted by the mean squared, because sometimes that will give you a negative value, and then divided by all of the numbers in a data set, and then you square root that number, and it'll give you, on average, how different this population is, this sample population rather, is from the population at whole compared to a normal curve. We will do work with this in class, so if you don't understand it, write down any questions you have and bring them in and we'll go over them. We won't really be doing many standard deviation calculations by hand because calculators and computers can do them very quickly and very easily. But this is a very important measure that psychologists use to compare samples to whole populations. So if you can, as you can see, you can very reliably measure what percentage of the population falls under a certain standard deviation. So if you look at one whole standard deviation below the mean, you know reliably that about 34%, 15% plus 19%, because this goes by half of a standard deviation, falls under one standard deviation below the mean. In other words, on average, 34% of the population is spread away from the mean. In addition to comparing means to a normal curve, you can take individual scores and compare them to the average standard deviation. This just is a way of measuring individual scores and seeing how they compare to the average. So, if you wanted to see about how far away your score was away from the mean, all you had to do would be to calculate your z-score. We will be getting a lot of work done in class with both of these values. So please, if you have any questions on how either of those are calculated, write them in your notes and bring them into class, and we'll handle them when I see you next.